In this video, we're going to talk about graphing two variable equations. The learning targets for this video, students will be able to write equations in two variables to represent relationships between quantities and graph equations on a coordinate plane. For line equations, one super important thing that you need from Algebra 1 is to know how to find the slope, or what the slope means. The slope for a line, we use m to represent it, and it is just the change in y over the change in x, something super important that you need to know. That's the constant rate of change. There are three different forms that we can write line equations in. One form is called point-slope. Another form is called slope-intercept. That's the one we use the most. And the last form is standard form. We're going to talk about what those look like. Point-slope form is y minus y1 is equal to m times x minus x1, and we'll talk about what those things mean. M, like we set up here, it means slope, so m is the slope. And x1 and y1, or x1 comma y1, is just some point on the line. It's some point on the line. Any point on the line. You can use, so m is the slope, and these pieces here, x1 and y1 collectively together make a coordinate that is a point on the line. For slope-intercept form, we have, y is equal to mx plus b, where m is equal to the slope and b is equal to the y-intercept. It's the point that intersects with the y-axis, point of the line that intersects with the y-axis. And so this coefficient for x is the slope in this form, and the b, the thing that I'm adding, is the y in the y-intercept. Standard form is ax plus by, where a and b are integers, is equal to some number c, some integer c. So a, b, and c, like I just said, it's important that they are integers. So they shouldn't be fractions, they are integers. And in order to find the slope from standard form, you can do negative a over b. That's the coefficient for x over the coefficient for y. And that is the slope. We can highlight this in red. Okay. All right, so let's do an example of graphing from slope-intercept form. So for example, maybe I have the equation y is equal to negative 1/2 x plus 3. That means that the coefficient for x tells me the slope. So I know that the slope, or m, is negative 1/2. And I know the change in y over the change in x, which I know it means how I'm moving on the graph. I'm moving, change in y is up and down, so I'm moving down since it's negative. Down 1 over 2 tells me the change in x, and it's positive, so I'm moving right, 2. X tells me left and right, sorry. I also know from slope-intercept form, this thing that's being added is my y-intercept. So I know that the y-intercept is 0,3. And so I'm going to plot 0,3 first. That's how I'm going to start the line. And then I know that my slope I can use down 1 to the right 2. So down 1 to the right 2, and I know I'll have a point here at 2, 2. I can keep doing that. Down 1 to the right 2, down 1 to the right 2. And I know that I only need 2 points for a line. Oh, come on. I only need 2 points for a line. So I didn't have to do all of that, but I connect them and make sure it's going through all of the points. That's good enough. And I know that lines are infinite, so I include 2 arrows on either end. That's the graph for slope-intercept form, from slope-intercept form. Graphing from point-slope form, let's do an example of that. So, for example, point-slope form, y minus 3 is equal to 5 over 2 times x minus 2. This is an example of a line in point-slope form. What I can gather from this is immediately I have this is the slope. This coefficient is the slope. So I know that the slope of my line is 5 over 2. I know that's the change in y over the change in x, which means I'm moving, y tells me up and down, so I'm moving up 5. X tells me left and right, I'm moving positive right 2. I also know one of the points on my line. So what's being subtracted from the y is my y coordinate, and what's being subtracted from the x inside the parentheses is my x coordinate of the point that I know on the line. So the point I know on the line is 2, 3. And so I'm going to plot that point first. I'm always going to plot the point first and then apply the slope. So 2, 3 is my point that I have, and then I'm going to apply the slope, which is up 5, 1, 2, 3, 4, 5. So up 5, and to the right 2. Did I do this right? 1, 2, 3, 4, 5. Okay, yeah. And then this, I have a point at 4, 8. I only need 2 points for a line. I should have 3, but I only need 2. And then I make sure I include those arrows at the end to show that the line is infinite. It goes on and on forever. Graphing from standard form, an example, maybe you have 3x plus 2y equals 12. The easiest way to graph is to find the x-intercept and the y-intercept. To first define the y-intercept, I know that for a y-intercept, x is equal to 0. So I'm just going to plug in x is equal to 0 into this equation. So I'm going to have 3 times 0 plus 2y is equal to 12. All I did was I took 0 and I plugged it in for x in my equation. I end up with 2y equals 12. The 3 times 0 goes away because it's 0. And then I divide both sides by 2, and I find that y is 6. So I know I have the point that when x is 0, y is 6. This is my coordinate that I'm going to put on the graph, 0, 6. Oh, I already did this. Whoopsies. Oh my gosh. Why isn't it letting me? Okay, whatever. And then the other point that I want to find is my x-intercept. So my x-intercept, that means that y is equal to 0 when I have an x-intercept, when I'm intersecting with the x-axis. Y is equal to 0. And I'm just going to plug in y is 0. So I have 3x plus 2 times 0 equals 12. All I did was I took y and I took 0 and I plugged it in for y. I know that I'll end up with then 3x is equal to 12. I'm going to divide both sides by 3, and I'm going to get that x is equal to 4. So for when y is 0, x is 4, I have the point 4, 0. These are 2 points that go on my graph. So 0, 6, nope, that's not 0, 6, 0, 6, and 4, 0. And then I connect them with a line and make sure that I make that line infinite. Another thing I want to be able to do is write equations given points. So if I'm given 2 points on a line, I want to be able to use them to write an equation for the entire line. If I have 2 points, what I can find out from them immediately is the slope, and that's what I'm always going to do. If I'm given 2 points, first thing I'm going to do is find the slope. I can use the slope to find anything else that I need to for the line to complete the equation. So first thing I'm going to do when I'm given 2 points to write an equation is I'm going to find the slope. I like to write the 2 points on top of each other. That's what works best for me. You can do whatever works best for you. If you want to use the equation, it's y2 minus y1 over x2 minus x1. That's the change in y over the change in x. So you take, you can make this x1, y1, and this x2, y2. I like to put the two points on top of each other, like this. And I like to look at the change in y and change in x from there to make sure that I'm lining them up and doing them. I'm going from this point to this point for both the x's and the y's. From 8 to 9, that's the change in y. And I know the change in y is positive 1. That's the change in y. The change in x, I know going from the first point to the second point is 2 to 5 is positive 3. So the change in x is positive 3. Then I know that my slope is the change in y over the change in x, and I just plug in what I got. I have 1 over 3. So my slope is 1/3. That's my slope. The easiest form for me to go from there is if I have a point on the line and the slope is point-slope form. I have a point, I have the slope, point-slope form. The second easiest form is slope-intercept. You can also go between each type. So if I wanted to do all 3 different forms, show all 3 different forms for this example, easiest to start with is point-slope form. And so I would write the equation y minus 8 is equal to 1/3 times x minus 2. So I just took this point here, 2,8, or I was using blue for this, 2,8, and I plugged it in. So this is what I'm subtracting from the x, this is what I'm subtracting from the y. And I put my slope in there. Here's my slope. What I'm going to do from there is so that's my point-slope form. This is my point-slope form. Oh, black. That's my point-slope form. And I want to I can convert that into slope-intercept form. So I'm going to practice doing that. To convert that into slope-intercept form, I need to solve for y. Slope-intercept form has y by itself. So what I want to do when I want to put something in slope-intercept form is get the y by itself. To get the y by itself here, first thing I'm going to do is I'm going to multiply the right-hand side by 3. So I want to undo the 1/3. I'm going to multiply by the reciprocal. That's 3 over 1, or just multiply this entire side by 3. If I do that on the right, I'm going to do that on the left. So I'm going to multiply everything on the left by 3. I distribute that 3 to the y and to the 8, and I'm going to end up with 3y minus 24 is equal to, on the other side, 3 over 1 times 1/3 just gives me 1, so this cancels, and I'm left with just x minus 2. From there, I want to get the y by itself, so I want to add 24 on both sides. And I end up with 3y is equal to x plus 22. And then the last step, that's what 3y's are, x plus 22, but I want just one y by itself, so I got to divide that x plus 22 into 3 equal parts. So I'm going to divide by 3 to get that y by itself. Do that on the left and the right. I get y is equal to x divided by 3, remember, distribute that dividing to the x and to the 22, x divided by 3 plus 22 divided by 3. I can rewrite this just a little bit better to be y is equal to 1/3 times x plus 22 over 3. This is my slope-intercept form. So that's my slope-intercept form. Oh, God. Slope-intercept form. I could start from here and then go to standard form, but I could also just take this part here and convert that to standard form. So I start with 3y minus 24 is equal to x minus 2. Oh my gosh, my pen isn't working. And then just to get my x's and y's on the same side and my constants on the other to make it standard form. So I'm going to subtract x on both sides. I'll get 3y minus x minus 24 is equal to negative 2. Then I just add 24 on both sides. And I get 3y minus x is equal to 22. When I'm writing standard form, the only thing I need to keep in mind is I cannot have fractions. I have no fraction coefficients here. This is my standard form, and I'm done. The other way, I said the easiest form to start off with was point-slope form. You don't need point-slope form to find slope-intercept form. You could also find slope-intercept form. I'll show you another way to have done that. So another way to find slope-intercept form from the beginning. I know that point-intercept form is y equals mx plus b. I found m was 1/3. So I have y is equal to 1/3 times x plus b. I have 3 variables here. I can't solve a 3-variable equation. I can only solve a 1-variable equation if I have just one equation. So I need to somehow eliminate 2 of these variables. And what I can do is I know an x and a y that actually go together. So I have 2, 8. 2 as x goes with y is 8. So x is 2 goes with y is 8. And so I can plug in the point 2, 8 here. This is my x, this is my y. And I can say, when x is 2, I know that y is 8. And this equation is satisfied. And then now I only have 1 variable that I can solve for. And so first thing I do is clean this up on the right-hand side. 1/3 times 2 is 2/3 plus b. Then I just subtract 2/3 on both sides. And I get that 8, so I have 8 minus 2/3 is equal to b. 8, in order for me to combine 2 fractions together, I need the bases to be the same, so I'm just going to convert 8 over 1 into, I'm going to multiply by 3 on the top and bottom, a giant 1, so I don't change the value of the fraction, and I'm going to end up with 24 over 3 minus 2/3 gives me b, and that means that b is 22 over 3. So again, I have y is equal to 1/3 x plus 22 over 3. It's just another way to get there.